sac228 problem number 1, we're supposed to construct a ray tracing diagram for a diverging lens. Let's get started on that. We'll draw a principal axis for the lens. Usually fold the sheet of paper in half to get a good principal axis on there. Then we need to draw a plane of the lens. And then we should draw an icon for the lens. Let's see, I might need a little more room up top there. I'm going to move that one down one. This piece of paper is a Word document. It's been marked off with a 1 centimeter grid. I've prepared an icon of a diverging lens, and right now I got it set so everything snaps to the grid, but I want to put that right. I want to be able to place that wherever I want it. Actually, it wasn't bad the way it was. So let's leave it there, and then I got to put some focal points on there. There's one of them. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters from the end. So pop that right in there. And let's blow it up a little bit. Get that focal point in the right spot. So center it right on the lines there. And then need to label that one. So little F just below it. And then going to do the same thing over here. Let's put the focal point. This one goes at 1, 2, 3, 4, 5. A bit further over than that. 6, 7, 8, 9 centimeters on each side. I do want to recheck that. It was, focal points each 9 centimeters from the lens. That one's centered a little bit better. And then label that with a big F. And I got the focal points on there. Let's see what this thing looks like. Where we can see the whole page. And then I'm supposed to put an object on there. I want to snap that one to the grid, get it right on the centimeter mark, because the object happens to be 7 centimeters tall and it's 12 centimeters from the lens. So make that object an arrow. That's 9, 10, 11, 12. So it would be all the way over here. And it's 2, 4, 6, 7 centimeters tall. Okay, now we're in a position to draw the principal rays for this object. We need one that goes, I'm going to take principal ray number 1. It's headed toward the focal point on the other side. Let's go ahead and draw a line that's headed toward the focal point on the other side. And I can't make it pass through the focal point like that, so get rid of that. And then make it pass through the focal point on the other side. Let's snap them to other objects. So I need an arrow that travels along that line. This will be my ray, goes right along that line. So right from this point to that position. But instead of continuing along this line, think of that as an edge of a ruler that I was using, it heads out parallel from there. That's what principal ray number 1 does. Continues along that path. Alright, principal ray number 2, an easy one. heads toward the center of the lens, and it just keeps right on going. And I want to make it obvious that that's a ray rather than just some line. So put another arrowhead on it. Okay, principal ray number 3 is coming in parallel. Let's draw principal ray number 3. It's coming in parallel, gets all the way up to the plane of the lens, and then starts diverging as if it was coming from the focal point over here. I want to draw a line there temporarily. In fact, I'll make that a dashed line. And I can probably leave it on there for traceback purposes. So draw a dashed line right there. It looks like let's blow this up a little bit. Yeah, it's pretty well going straight through the focal point. Okay, now it diverges as if it's traveling along that line. And what I'll do is extend this one to help me out on that. And then the ray itself heads on up in that direction. So it comes in this way, leaves the head, the tip of the head of the object. When it gets to the plane of the lens, notice this is just an icon, so all the actions happen at the plane of the lens. If the lens is big enough, this ray will actually do that. If not, the rays that form the image will form the same image that this would. Okay, so it heads in and parallel to the principal axis of the lens, and then it diverges as if it was coming from the focal point. Heads on out in that direction. So we got all 3 of them. 2 of them we can see where they cross. First off, they're not coming together on the other side of the lens, so we're going to have to use trace back, and that's why I left this dotted line on here. This one, if we trace it back, well, once you go beyond the lens, you're still in that same area. So I'm expecting the tip of the arrowhead of the image to be about right here. This guy's got to be traced back in order to determine where it extends back, and I'll go ahead and do that. Trace it back. So, and I'm going to change that one to a dash line. It's just a trace back. So this part of it is traced back, and this is the actual ray. So it was coming toward the focal point on this side and came out parallel. One of our 3 principal rays. And now I can see this is right where the image is formed. Of course, we got to put the arrowhead on the top of it. And there's our image right there. So the distance that it is from the plane of the lens, right there, this is the plane of the lens, this line. The distance that it is from the plane of the lens is the image distance. Well, we've got our principal ray diagram. Ray number 1, I'll call it from top to bottom. Renumber them if I already gave them some numbers. Ray number 1 coming in parallel. It shoots out, traveling along a line that passes through the focal point. So it shoots out as if it was coming from the focal point. Ray number 2 comes in toward the focal point on the other side of the lens, and then shoots out parallel. It's caused to diverge. It was converging toward the principal axis, but this diverging lens renders it parallel. And then principal ray number 3, this bottommost one, just goes straight through the center of the lens. It's headed toward the center of the lens, and it just keeps on going straight through. And these all did cross pretty close to a point, so now we just have to measure things off. I've got 1, 2, 3, 4, 5. We'll call it 5.2 centimeters. You could use a ruler, and you should actually be able to get it down. You can see the nearest millimeter and then interpolate beyond that. But let's see what they're asking for here. Construct a ray tracing diagram. They want the position of the image. Alright, by definition we say that the object is in front of the lens. So we've got an image that is in front of the lens. And let's see if I got make a text box here and just see if I can type our answers in it. The part A, image is, and we measure it with a ruler. 1, 2, 3, 4, 5.2. It's in front of the lens. 5.2 centimeters from the plane of the lens. Okay, part B. Let's see what they want there. They want the absolute value of the height of the image. So we measure that carefully with a ruler. I get 1, 2, as near as I can tell, it's 3 centimeters. So image is 3.0 is about the best I can do. That last one digit is actually an estimate, centimeters tall. And part C, they want to know whether it's erect or inverted. It's erect, it's right side up. And then part D, they want to know whether it's real or virtual. Well, instead of these rays converging together on the other side of the lens, I had to use traceback because they were diverging from each other, and hence what we've got is a virtual image. And that's all they wanted to know about that. Image, so I think we're pretty well set. Just make sure you can read that. Make it a little bit larger, but we've got we've answered the questions and created the principal ray diagram. So let's call it a solution for SAC 228, problem number 1.